The universe is vast. Today, we explore a new idea. This idea is called the Nemonian universe model. It comes from a thinker named Nemo Jackson. Jackson looked at the stars and thought about space and time. He imagined a universe with many different kinds of stars. This model helps us think about the cosmos in fresh ways. It challenges what we thought we knew. It opens doors to new possibilities for exploration and understanding. Nemo Jackson is a visionary. He spent many years developing his model. His Nemonian universe model is not just about stars, it is about the fabric of reality itself. It talks about energy and different dimensions. It even talks about how time might work differently in other places. Jackson's work invites us to be curious. It encourages us to ask big questions. What if there are more stars than we see? What if they behave in ways we don't expect? So, let us begin this journey together. The Nemonian universe model is significant. It changes how we think about fundamental concepts. Take energy, for example. We know energy from Einstein's famous E equals mc squared. This means mass can become energy, and energy can become mass. The Nemonian model expands on this. It suggests that stars can tap into different forms of energy. Some energies might come from other dimensions. This could explain phenomena we do not yet understand. Space and time are also seen differently in this model. We usually think of 3 dimensions of space and 1 dimension of time. The Nemonian model imagines more. It suggests there are multiple dimensional zones. Stars in this model can align with these different zones. This could mean that some stars exist partly in our reality and partly elsewhere. This is a mind-bending idea. Imagine a painter with a huge canvas. This canvas is the Nemonian universe. The painter, Nemo Jackson, uses many colors of paint. These colors are the 24 different star types. Each star type adds a unique hue and texture to the cosmic masterpiece. Why so many types? Our current astronomy classifies stars mainly by temperature and size: red dwarfs, yellow suns, blue giants. The Nemonian model suggests this is just the beginning. It proposes a richer, more complex stellar zoo. These stars are not just different in size or color. These 24 star types have unique characteristics. They differ in how they are born, what kind of fuel they burn, and the light and energy they emit. Some might be incredibly bright, visible across vast cosmic distances. Others might be very dim, almost hidden. Some might pulse with strange rhythms. Others might have unusual gravitational fields. Let's begin with the first group of Nemonian stars. These are like the foundational elements. First is the proto-spark star. It is very young, a baby star. It forms from cosmic dust and gas just like our stars. Its lifespan is relatively short in cosmic terms. It burns brightly but quickly. It exists mainly in our familiar dimensional zone. When it decays, it scatters its material, helping new stars form. Next, we meet the ember star. This star is a bit older than a protospark. It glows with a steady warm light like embers in a fireplace. Its lifespan is longer, providing stable energy for potential planetary systems. It also resides primarily in our dimensional zone. Its decay is slow and gentle. It gradually fades, becoming a cool, dark remnant. Then there is the helioflame star. This star is much like our own sun. It radiates powerful light and heat. It is a source of immense energy. Its lifespan can be billions of years. It is a cornerstone of its solar system, firmly anchored in our dimensional zone. When a helioflame star ages, it might expand into a giant. Then it could shed its outer layers or, if massive enough, explode. The Azure Giant is a truly massive star. It shines with an intense blue-white light. These stars are very hot and very luminous. Their lifespans are shorter than helioflame stars because they burn their fuel so rapidly. They usually end in a massive supernova explosion. Now, we venture into more exotic Nemonian stars. Consider the quantum singularity star. It manipulates quantum foam for its energy. Then there is the chronoshift star. This star warps the flow of time around it. The dimensional anchor star stabilizes connections between dimensions. Meet the etheric whisper star. It radiates subtle energies, perhaps related to dark energy. The lumen crystal star appears as if made of glowing crystals. Its energy comes from resonant frequencies within its structure. Lastly, the umbral core star absorbs light and energy. Its core is incredibly dense. Our exploration continues with stars known for their dynamic power. The Solara Prime star is an enhanced version of a helioflame star. It is exceptionally stable and luminous. It often serves as the heart of vast, complex planetary systems. Its lifespan is extremely long and predictable. It is perfectly attuned to our primary dimensional zone. The Nova Bloom star is known for its periodic, brilliant outbursts. It's not a one-time supernova. Instead, it undergoes cycles of dimming and then suddenly flaring up with intense brightness. This cycle can repeat many times. Its lifespan is marked by these dramatic pulses. The Echo Remnant star is not a star that generates new energy. Instead, it is the cooling, echoing core of a much larger star that has already died. It still emits faint radiation like the afterglow of a great fire. Its lifespan as an echo can be very long, slowly fading over billions of years. The pulsar Heart star is a rapidly spinning, highly magnetized remnant. It emits beams of radiation from its poles. As it spins, these beams sweep through space, appearing to pulse like a cosmic lighthouse. The Graviton Well star possesses an incredibly intense gravitational field. It is more extreme than a typical neutron star but not quite a black hole. It significantly warps space-time around it. Its lifespan is very long, as its immense gravity holds it together. Finally, the Tachyon Burst star is a theoretical marvel. It is believed to emit particles or energies that travel faster than light tachyons. This is highly speculative, of course. Its lifespan is unknown, as are the true properties of tachyons. It would be aligned with dimensions where superluminal travel is possible. We now approach the most enigmatic stars in the Nemonian universe. The Null Field star is a curious object. It appears to generate a region around itself where certain physical forces are dampened or nullified. For example, electromagnetism might behave strangely near it. Its lifespan is tied to the stability of this null field. The Entropy Eater star is a fascinating, almost paradoxical concept. Entropy is the tendency for systems to become more disordered over time. Stars burn fuel and increase entropy. This star, however, is theorized to locally reverse or consume entropy. It would draw in disorder and emit order or refined energy. Its lifespan could be immense if it truly masters this process. Next is the Genesis Forge star. This star is believed to be a cosmic crucible where new fundamental particles or even new laws of physics are formed. It operates at incredibly high energies and densities. Its lifespan is likely tied to specific cosmic epochs or conditions. The Omega Point star represents an ultimate state of stellar evolution in some Nemonian theories. It is a star that has achieved a kind of perfect stable energy equilibrium. It might be incredibly ancient and highly evolved. The celestial mirror star does not shine with its own light in the usual way. Instead, it perfectly reflects or perhaps amplifies energies from other sources across vast distances. Finally, the Void Bloom star is a truly strange phenomenon. The lifespan of each Nemonian star type varies greatly. Some, like the Proto-Spark star, live for a relatively short time. They burn through their fuel quickly, in perhaps a few million years. Others, like the Crimson Dwarf or the Solara Prime, can shine for trillions of years. They are very efficient with their energy. The Nemonian model suggests that lifespan is not just about fuel. It is also about the star's connection to different dimensional zones, and how stable that connection is. This adds a new layer to understanding how long stars can exist. Dimensional zone alignment is a core idea in the Nemonian universe. Imagine our universe as one sheet of paper. Now imagine many sheets stacked together. These are the dimensional zones. Some stars, like our Sun, a helioflame type, exist mainly on our sheet. But other Nemonian stars might have parts of themselves in other sheets or dimensions. This alignment affects their energy, behavior, and stability. The Nemonian universe model, created by Nemo Jackson, tries to bring many ideas together. It's like making a big cosmic soup with many ingredients. One ingredient is classical physics. This is the physics of Newton, describing gravity and motion. It helps us understand how planets orbit stars, and how stars group together in galaxies. The Nemonian model respects these basic laws, but it suggests they are part of a much larger picture. It builds upon this classical foundation. Another key ingredient is the world of quantum fields. Quantum physics studies the very, very small. It tells us that energy and matter behave in strange ways at tiny scales. The Nemonian model imagines stars tapping into these quantum effects. Stars like the Quantum Singularity star or the Void Bloom star are born from these ideas. They suggest that the vacuum of space is not empty, it is full of potential energy. This energy could be the source for some of the more exotic Nemonian stars. Entropy theory is also woven into the Nemonian fabric. Entropy is about order turning into disorder. Most stars follow this path.